Python tutorial that I'll be giving you. I'll be teaching this myself. My goal in this is to have you understand Python and to be able to also understand how to decode or debug, should I say, to be able to use it now with AI and to be able to get a good grasp on it so you can get going with whatever projects or whatever things that you want to make as soon as possible, but yet still be able to have and still be able to use it very fluently with GPT, but also be able to understand what you're doing. To do that, I'm hopefully going to just try and get into it, just show you examples, kind of like how programming works just on the fundamentals. We'll go over that, and then we will go into everything else. We'll get into maybe not in this video, but like some of the further videos, what how it can be used with like GPT, and then also some other topics. The series is going to vary, but for the most part for this video I just want to go over the fundamentals. So anyways, to get started, what you're going to need is to make sure Python is installed on your machine first. So open up your browser, go to python.org. If you're on Windows, you can download the Windows version. The Mac, it has some instructions for Mac. If you're on Linux, go to your terminal and you're going to type sudo apt update, make sure your package manager is updated, and then go to sudo apt install python 3. Just to show you, I have the GPT right here. You just ask GPT itself and it'll tell you kind of how to install Python. After you have Python installed, you can go to a terminal real quick. Go to, I think this should work, Python 3 version. Okay, not Python 3. Python version. Okay, so Python 3 version will work for Linux, and then for Windows, you do Python version, and it should show just that the Python and then the version itself. For Mac, it's Python 3 version, so it's the first one that I typed in. Once you have that, you can show that Python's installed. After we have this, what you're going to need next is a IDE. Real quick, an IDE stands for Integrated Development Environment. It's basically software that's going to allow you to code or to write your code, to compile it, to be able to test it, to debug it. That's what an IDE really is. It's a tool that helps you develop software, to develop, where to write your code in, that will eventually allow you to build software. Because otherwise, the only other way you can write Python is you could edit it just with Notepad, but no one really does that. People have an IDE to edit it. It's basically almost a glorified, I guess you could say almost like a glorified file editor, but it's a file editor that allows you to edit, specifically meant for code and development and anything associated with programming and the making of it. So the most common one that I want to say is in most field is Visual Studio Code. There's many other IDEs. You can look online and just find which IDE kind of suits you. My go-to though is VS Code. I'm sure you'll see this a lot in the industry if you aren't already familiar. Once you have Visual Studio Code, what you're going to want to do is go to File, and you're going to go to Open Folder. You're going to make a folder that you want to work in. This is where you have all your Python files, because Python is just Python code is just a file, and everything that exists on a computer is a file. So make a folder in which you're going to work in. I already have that. I have it right here under my tutorials in Python, and then select this folder. Now what you're going to see is this little Explorer tab on the left. You're going to have it has like this little page icon. You can open it. You're not going to have this here. This is the Python file that I have. What you're going to want to do is create a new file, and you can call it main.py. Make sure this .py is there. The first part is just the name. It really doesn't matter for Python files, but make sure you have this .py. That is the extension, and that's what tells your whole computer basically that this is a Python file, and that the IDE and anything else that this is the Python file. So once you have that, you're going to see something that's pretty much blank like this. What you're seeing here, this open chat, that's just some of the extensions that I've installed with, some AI things. Don't worry about that. The first thing you want to type is print hello world. This is a program that most people are going to make you do. And to test it, you can either, what you're going to test it, you can either go to command prompt and navigate to the file and then do like Python and then type in the file. We're not going to do that. What you're going to want to do is you're going to go to the right over here. You're probably going to see this play button. If not, Visual Studio Code might have already asked you, would you like to install a Python extension? What this is Visual Studio Code has different extensions, or which are tools that are within Visual Studio Code, and you can see them right over here on this extensions, these little cubes on the side. I have many, but if you type in Python, if it didn't already recommend to you to install it, you're going to see that there's going to be this Python. It says Python language support. This is basically what's going to allow you to compile Python on VS Code, and it's going to allow you to just push this play button, and then you're going to see down here this little terminal tab. It's going to say, it's going to run the code, basically the Python .exe, and you're going to see that it's going to run hello world, and that's basically what your program is doing. It's just printing to this terminal hello world, just these words itself. So congratulations, you wrote your first Python code. It's that simple. You're probably thinking, well, what now? Is this really all it was? This is like, anyways, once you've done that, so I just had to delete that because it opened multiple terminals. We can get into something a little more, well, first let's explain this real quick. So you see that little thing on the side of that dot every time I change the code? That's just saying that your file isn't saved, so you can do Control S and that will save your code. I think there's ways you could change it in Visual Studio to like automatically save, but for the most part, most of you are going to have to like save it every time you make a change. You could do this. Okay, so even when you push play, it should save too, but I usually get into the habit just doing Control S because like some of the other projects. So let's explain what this does. So print is just basically a built-in function that Python has. Is the best way I could explain it. It's not really a function. It's like some functionality that Python has built in, and it allows you to print in anything that's within these curly braces. So you can print anything that's in between quotations, and anything that's between quotations are called strings. You can also print numbers, so I can get rid of all of this and just put like 2 in here. If I save it and then I run it, you can see that 2 is running down here. And if you want to clear this, you can just do clear, or you can also, I think if we can also just do, I don't know if there's any, yeah, clear terminal. So you can just do that as well. There's just a little, oops, just these little 3 dots, and there's some other options, but clear terminal and they'll get you going. So you can do that. You can do math in this, you know, basic math in it. You can run it. It's got 4. You can do like 10 divided by 5, and that's gonna have 2 as well. It doesn't really matter. The other thing you're gonna notice is that Python has white spacing. Obviously, we're not gonna see that yet, but that might matter when it comes to your code. As you can see, if I put a tab right here, we're gonna get error right away. So that's another thing with Python. It's white space sensitive, I guess we could say. I don't remember what the correct term is. So basically, if you have a tab or just any spacing in this, your code won't compile. You could see that. If I run it, you're going to see that we're going to get indentation error. That's because Python has indentation based syntax. Syntax just basically means it's like grammar or the spelling for the, you know, the word that's used when it comes to code. It's like the grammar for the code or the spelling for the code. That's all that syntax really means. So when we say indentation based syntax, it just means that it's you know, white space or blank spaces. It's sensitive to it in the text or format or the language is the best way I could say it. So if you have a problem with it not running, that's probably maybe one of the reasons. Or if you get the indentation error down here, that's why it didn't run. And it'll even tell you like on the line as well. That's part of the debugging. Anyways, so you can do that all in just like this little print statement. Whoops. Now we can get into something else, which are variables in Python. Variables are basically what you think you are. If you've taken any algebra class, you've probably seen that you've had X or Y, solve for X or Y or just anything like that. That's what a variable is. It's just this placeholder that can be anything. We can kind of show that here. X is equal to 1 is basically how you would write a variable in Python. And then we can even print this x, and you'll see that this will print 1. That's what a variable is. It's just a placeholder to hold, some kind of value, and then it's represented, everywhere else within the program, basically, at least in this context. We'll get into more about that later, but basically know that a variable is just a placeholder that we can set it to something, but it can be, a variable is basically anything, and we can show this by saying that it can be equal to 2. You will see that Python will resolve this as being 2 when you run it. And that means just because we set x to 1 initially, and then we're changing it to 2, so print will check the most recent statement. All these are actually considered statements. Every single line of code is pretty much considered a statement. We'll get into the difference between what is and what isn't a statement later on, but just know that most lines of code are going to be considered statements. Like variables are statements. This print portion is a statement. There's going to be some other stuff, but know that when I say statement, so far it's just going to mean every line of code. So our first statement, x is equal to 1. Our second statement, x is equal to 2. And then our third statement is going to be print, and what it's printing is x. And that's going to check the most recent variable. You can even say, if you hover over it, it's going to say in the literal 2 because it already kind of knows it. And that's, the most recent thing that it's set to. There's other languages which might change that, but we can get into that later. That doesn't really matter. But most languages, they're going to have kind of like this recent callback, that the most recent thing that the variable is set to is going to be x. So yeah, that's what a variable is. We can also set x to other stuff. We can set it to a number, and then we can even set it to a string as well. So we could set it to hello world again. And if we save it, you will see that it's going to print hello world. We can change it to a arithmetic expression. So we could do 10 divided by 2. We could save that, and we'll see that we're going to get 5. It's actually going to print 5.0. We'll get into that a little bit later. So yeah, this is kind of like your first things that you're going to work with in Python is variables. Print is going to be kind of like the thing that we're going to use to kind of see what's actually going on within our program, or it's the easiest way that we get output outside of our program. We don't have any input into our program. We're just basically the person that's making it and writes the black box, so to say. If you're familiar with like the black box concept, it's just like our program's doing something and most people, they don't know what it is. And that's kind of like what all these variables and basically what we write in the program is going to do stuff. So that's variables. We can get now into data types. I feel like data types will probably be the best next thing that we can get into. I had to get some coffee there. I haven't had much sleep. So data types are basically, Python doesn't explicitly tell you what data types are, but data types are basically needed in every single program. And to show you this, you've already seen 3 of them so far technically, but the main ones that you can rarely tell is numbers and then strings. So anything in quotation are going to be considered a string. We can even put a number inside the string. This is still going to be considered a string even though there's a number in here. So we can see this, that when we print it, it's going to print hel3, and you're probably not going to be able to tell the difference from the output, but the main reason that you're going to tell that it's going to be a string is going to be that it's in quotations within your program. Another way that you could tell, another way you can explicitly tell is by typing this other function within print, and then we could put a variable here. You don't even have to put a variable. You could put like the string itself. We could put a string. So like we can do type, put it 2 quotations, and it could be like hello. And you'll see that it's going to print a class within these triangle brackets as good as str. This stands for string. You could put a 3 in here. You could save it, run it. You can see that it's printing an integer. So integers are other type. It's not just considered a number. Integers are other type. The other type that you also saw was a decimal type, which is considered a float. So if you put like a dot and anywhere where you put a dot in a number, Python's going to resolve this to a float. Kind of just hang in with me in here. I know it's going to be like a little bit confusing here, but like what is he getting into? Why do we even need this? Just know that Python and any programming language is going to have classifications for data. That's what these typings are. The classifications are needed to basically have the computer know what the data is, because computers just run in ones and zeros. So the computer doesn't know that what 2 is, for example. The computer can't physically understand 2. So when they started making languages and programming languages, and they had to make data types to kind of convert these numbers that are represented in ones and zeros, or strings that are represented in ones and zeros, and a way to kind of convert that data into like actual numbers, like the decimal number system, or to convert it into like strings, or to convert it into how would we represent decimals. This is a problem that is in computer science or in programming, where data has to be represented some way. So know that in programming, your fundamental types that you're given so far that we know of is string, integers, floats. The other ones that you're going to come across is booleans. So we can get rid of all of this. We don't need these variables, just controlling them. So we could put true, and Python's going to resolve this as a boolean. You're going to see that. If we print that, you're going to get bool. We can even do this with the variable, showing you just also that this type command right here, this type function, keyword. There's many different things that people will call them. Can also resolve stuff in variables. So we can do that. Oops, we got to put this in here. So you can see that it will resolve to bool. The other type, which also is a decimal. So you can see another type that in Python that's really common in other languages. So another data type that you can see in Python that is kind of common are lists. Lists are just this structured way of containing items. They can contain anything. They can contain strings. They can contain decimals. They can contain booleans. But the whole data type itself is just the list. This is what's being saved to X. So if we print this, you'll see that it says it's a list. And we'll just have that for now. But know that like the main things that are fundamental to all languages, and not just Python itself, is data types. So we can kind of move on from that. Just know that Python doesn't explicitly tell you the types unless you look into them, and types are more to kind of have you understand how programming works. They come more in like if you want to get into like lower level languages and more into efficiency. But just know like a fundamental thing is that data types do exist. They don't matter a whole lot in Python because you don't really have to explicitly tell Python that there's certain types. Python does a lot of this data management in the background, so you don't have to worry about it. But know that data has to be stored somehow. It has to be converted somehow. Data types do exist no matter what, because every computer has to convert the ones and zeros to some actual tangible or like some other data that we can see or type out and be represented. So we can move on from data types and variables. And we can go now into conditionals. I think conditionals would be a good, easy thing to understand next. So in Python, you're going to have if statements. And basically how if statement looks is something like this. This would be like an if statement. I think all this should be indented except for this. This can go back. Yeah. So if statement, basically what you could write is your if 5, and this portion right here is your conditional. And then you're going to have these two semicolons, not semicolons, the colons right here. So you have your if, your conditional, which in our case is 5 greater than 1. And then your colons, you're going to have some kind of statement down here. It could be print, it could be anything. And then make sure it's indented. This is where the indentation comes in. This is going to be your pretty much first experience where you're going to need an indentation. You're going to have tab or 4 spaces. If not, the code will not work. We can see this, and you saw the errors earlier. It won't work. You're going to have an indentation error again. So make sure it's indented, and you won't have any errors. And then we have else here. We don't actually need any of this. You can just have this, and you turn that off or something because it's distracting. So we could do if 5 is greater than 1, it's going to print 5 is greater than 1. And you'll see that it does print that. Just to show it more clearly, that's basically a conditional. We can also get rid of this and show this raw value itself, and that's going to be the data type that you saw that was a Boolean. So we could put if true, print 5. You're going to see it's printing 5 is greater than 1. But if I put false here, which is the only other Boolean data type that exists, there might be like some other stuff, but the main two Boolean data types that exist is either true or false. We can run this and we'll see that this won't print anymore. You can kind of see that it kind of got like ghosted out, or it faded a little bit, the text, because the IDE or the editor itself knows that this code won't run. To exit out of that, we can also see that we can write another print statement here, and we'll see that it prints hello world. And that's because this down here is what gets ran if the condition is true. This condition right here, if it's true, anything within indentations is what's going to get ran. This is considered a statement block, anything within indentations. So like this can be part of it. We could see that if we write another print, it says this will not be printed. The AI already knows that. We can go down again. Okay, if I can even, it already knows that. This is basically an AI tool that's already running in the background. You might not see this yet, but it's, you know, it's helping. The AI already knows that this code won't run. But yeah, anything in this indentation, this is basically considered a statement block. Usually you would see this in other languages as curly braces, or you would have two curly braces that are similar object-oriented languages. They would have curly braces for any statements that are like if statements or functions. And we'll get into what functions are in a little bit. Just know that these indentations are kind of going to be what separates different logical portions or statements of code. So we can change this back to true, and you will see that all of it will print now, not just hello world. We'll see that 5 is greater than 1. This will not be printed. Will print now, and hello world will be printed. So the other thing you saw earlier was a else statement. And else is basically a way to still how do I put it? Organize our logic again. That like if this is false, then this is going to be run. I'll show you kind of how the logic plays out with this. I can make this false, and the else statement will print now. 5 is not greater than 1. This will be printed. So this portion, you could see that this portion is what got executed when I had false, but that doesn't necessarily mean, if I write true, we will see that the way to kind of distinguish this, the best way that I can show you, I said if we write true, this is the only portion, the highlighted portion is what gets printed. So you can run that. 5 is not greater than 1. So you can see this up here got printed. Another way, just to make it simpler for you guys, because I know it's printing out a lot of stuff, put like 1 here, and then we'll just put 0 here. So you can see that it's printing 1 when it's true, but it's not printing the else statement. This only prints if this results to false, all right? But to show you something else, we can write print always. This is just, doesn't mean that this makes it always print, but it shows you that this portion of code down here, where there's no indentation, always gets printed, whether this is true, which we can see right here, it prints 1. It goes down to this line of code. It skips it because it's no longer part of this whole statement. And this is like a whole connection here. If and else, they kind of work together. And I'll show you, kind of stick with me for a second. But print this, anything after that will always be executed pretty much, or it will continue on with code after this. Like this whole segment is kind of together. If we change this condition to false, just to kind of show you more about what I'm meaning or trying to express or tell you, we could say that it's print 0, and that always will always be printed. But we see that 1 is no longer printed in this run. So know that this code in the else statement is dependent on the first if statement. You can't have an else statement by itself. This just doesn't work. Else has to work with if. All right, you have to have an if and then an else. Another way you can kind of play with this is just be like if, let's go back to that previous code so I can kind of show you something. So we saw that this portion doesn't get printed when the first portion of the if statement is true. We can see that 1 gets printed, but it gets printed when it's false. But we can also just get rid of this, and we can put 0 back here, and we're going to see that 0 is now printed all the time. So that's basically how else works, if and else work. They kind of like switch between each other, at least what the else does. If it's like false, the else portion will get printed. If it's true, the true portion will get printed. Anything outside of that if and else kind of combo will get executed as it's supposed to be functionally executed, or like it'll continue on. We can see we can do variables in here. We don't just have to do print. We can do print. If true, we can do x is equal to 1. And we can put our else here. X is equal to 2. And then down here, we can just put our x just to kind of demonstrate a little bit more further and how logical processing works. So if we print this, we'll see that it will print 1. Just to show you again, 1 gets printed when the condition is set to true. X is set to 1. Otherwise, x is, we can see that we've put false. You could probably predict it. X is going to be set to 2 and it's going to print 2. So those are those two things. I'd recommend you take a break right now. I know this is probably a lot to take in right away. Take a break, maybe try this out. I highly recommend that as you're going through this course, that you pause and follow along and type out some of this code, because the only way you can learn things is honestly by doing stuff or by doing things. I find if you struggle with math, one of the best ways that I find learning math, or the way that I think that doing math, is just by sitting down and doing it. I know that's a very hard thing for a lot of people to do, especially for math, and this is very similar with programming. If you find that you don't like math, or like this logical side of your brain, or you just can't sit down and just do like this very boring logical task, and that's basically what programming is. It's very boring. Like I don't like it for that reason, but I do like logical stuff enough that I'll do it. But my best advice to you is, like, as you're going through this, or like anything that you want to learn in life, actually sit down and like pause the videos and follow along as you go with them. That's kind of just how it works with programming. The learning curve is very much like doing math itself. So if you haven't already downloaded Python and all that stuff, the IDE, and gotten the IDE set up and got the code running, and haven't been following along, please pause the video, go back and type all this stuff in. This is going to be like your quickest way to do it. I know it takes time, but like if you follow along, it's the best thing for you. And I promise that to you. So once you have this, we can continue on the show. You might be a little bit curious now. What happens if we set this to false? We don't want the else in here. I really hate that it does that. And we just set x equal to 1. What will this print? You can kind of see that it's giving us a warning. X is not defined. If we run this, we will get an error, and a name error, and it says x is not defined. Why is that the case? Because this portion of code never got executed. You can see, you kind of understand that by now. X never gets defined. You know what I mean? This code, it's not read really. So if we go, sorry, I for some reason started Python running. So we can see that, oh my God, I just did it again. We have to define the variable x right away. And we'll see that if we run this code, x will be set to 0 or whatever we set it to. And this code never gets executed. So that's another mistake that you can make with it, that you might get errors by. So far, the two errors that we come across is indentation error and the not defined error. I forgot what it was explicitly called. We can run this again. It'll say it. The name error. These are two very common errors that you're going to see. Other languages have them named a little bit differently, just because of the way that they compile the code or interpret the code. Is the best way I could say it. But know that errors have names to them. As you continue on programming, you see that there's going to be many different errors that you can come across. Not a ton, but it's going to be very good in kind of showing you how to debug code or how to figure out where problems are. I encourage you that if you have code and you haven't figured out why it's working, just copy your code and paste it into GPT, and it'll kind of tell you like where the problem is, or explain to you a little bit more, and you can kind of have a conversation with GPT and like what's going on. Just know that for now, we're just trying to understand code as much as possible, as fast as possible. That way you can kind of get into using, coding also with using GPT. That way you can get into making stuff really quick. But know that like the only way to really understand this is just by like typing out programs and doing like small little projects first, or like learning all this basic stuff that I'm trying to teach you now. So now that we've gone over conditionals, we can also see that, we can make this a false statement as well. Like 5 is not less than 3. So you see if we save this, we'll see that we get the name error again because this code doesn't get ran. Obviously, like it can't really tell this because this isn't really explicit, but it knows at 5, this will resolve to false. We can also put a variable within our conditional. So we can make a variable. You can also make variables, longer. So we can make them longer. We could set them to false. We could see this, and we could put my condition. It doesn't have to be just one letter for the variable name. We can make the whole variable name a lot longer. Also, another thing to note with variables, the left side will always be set to the right side of the variable. It's just like math. The left side will always be set to the right side, or like you read it from left to right. So my condition will be set to the right side, false. Just know that with every programming language, the left side is always set to whatever the right side is. So we have this variable. We can use it now as our condition. Now if we run it, we push play, we can see that it's false. We still get that error. If we set it to true, if I can type, we can see that it gets set to 1. All right. So after conditionals, we can start going into, I think the next thing that it's probably most fundamental, and this is probably a little bit of a harder topic, is functions. So not functions, loops. So when we get into loops, the best way I could put loops is, or explain it, is that loops are going to be something that repeats over and over again, is what the loop does. It's going to be based off of a conditional. You're going to see this now. We can do the best, probably the easiest one that you could experience so far is going to be your while loop. So you're going to type in while. This is the keyword, just like if, just like print, just like else. You type in while inside these braces. You actually don't do braces. That's like for other languages. You're going to do this, and then you're going to have your conditional here, and you're going to see now that we're going to have a infinite loop. So we can just do print hello world. We're not going to do what it says because that's not what I'm trying to demonstrate. You're going to see that we have an infinite loop. So what you're seeing is that while true, this gets printed as many times over and over and over and over and over again, forever. This won't break your computer. This isn't enough to break your computer. It's just going to, run your CPU infinitely. Your operating system is what restricts your computer, or like tells your computer not to break, or tells this program not to like overrun the computer. Your operating system, handles all the security. It handles all of the programs and the allocations for CPU, or like the processing power of your computer. That's why this doesn't break your computer. A lot of people get scared, like, why are you typing this or something like that? This doesn't break it. So there's that. That's how your first experience to a loop. To get this to stop, we can just do a condition. We could print false. You'll see that this won't get printed at all once you run this. So let's, to end this, just do Control-C. I think it should work for most computer devices, or most devices. If not, you can just kill the terminal. That should end the program as well. So we can clear this now. And then if we run this, you'll see that nothing happens in this program. That's because it's set to false. So this loop never executes what's inside this block, basically right here. And notice that the indentation is used with this as well. Basically anywhere that you see a colon, know that there's going to be like indentation that follows afterwards for what gets executed inside that loop. So where loops become powerful is we can set how many times a loop runs. The easiest way to do this is by having a variable. It's going to be kind of like our counter. We could call it a counter. We could set it to 0. And we could say, while our counter is less than 5, for instance, we can print hello world 5 times, or we can even print our counter. I think the better way to explain this, make sure we don't put it within, you can use it within this, within parentheses, and we can do +1 within here as well. Well, actually, not that. To actually increase counter, we need to do counter. It's going to be equal to counter +1. It's going to be the simplest way to do it. So let's go through this real quick before we run it. This is an exercise that I recommend you practice, is go through your code line by line and figure out what each line does. So counter is our variable. We set it initially to 0. We have our first portion of our while statement. We have our conditional right here, which is the counter is less than 5. This is what it's going to evaluate every single time we go through the loop. So while it's going to look at counter, this condition, and it's going to say, is counter less than 5? Well, initially counter is equal to 0 right now, and 0 is less than 5. So this is going to result to true. And we saw that if something is true, it's going to execute what's inside these blocks or anything that's indented. it's going to print counter. So counter right now is 0. And then it's going to increase counter by saying counter is equal to counter plus 1. And I don't think we've had the variable within here. This might be a little bit confusing, but if you know like a little bit of math, kind of think about what this will print. And we can see that it prints 0, 1, 2, 3, and 4, all the way up to 4. Why doesn't it print 5? Because when we have 5 in here, 5 is not less than 5. So this statement becomes false. So if we have basically the final iteration of this, it'll come up and check 5 is less than 5, and this is going to be false because 5 is not less than 5. So I get to put this back here. You can see that even if we put this, none of this code will run. That's basically why 5 doesn't get printed. Okay, so let's explain this a little bit further. I know you probably might have a few more questions. Going back to this portion, you haven't seen this yet. We can set variables to themselves. So if we get rid of this, this is totally valid. We can have counter set to counter, and this will basically make an infinite loop again because we're no longer increasing our counter. That's basically what this statement was supposed to do. It was supposed to increase our counter, but since we're no longer adding 1 to it, you'll see that this will run infinitely and it will print 0 infinitely. And to explain this, stop this program real quick. I'm gonna have to kill it. Okay, so we can kill the terminal. To explain this, we can go through this line by line again. We can see that counter is set to 0. Counter is less than 5. This resolves to true. On this line, we can go to our next line. We see print counter. It's going to print 0. And then we're saying counter is equal to counter. So we're just saying, you know, our counter, our variable is equal to whatever counter is. And what this is going to do is it's going to check our variable up here. And it's saying that it's 0 right now. So remember how I was saying left side is set to the right side? It's just setting, you know, our variable right here. Left side, this is our variable set statement, basically, or it's doing a set. And it's saying that's set to our right side. This gets resolved to 0. This side gets resolved to an address, basically, of where counter is. We'll go into a little bit later, but just know that the left side is always set to the right side. Keep that in mind. Left side is always set to the right side. And the right side, in our case, is 1 plus 0 is what this is going to show. We need this so that we can always... There's no other way that I could really show this. This is just going to be, you know, what I'm trying to explain. This whole left is set to the right side is something you're just going to have to learn as we go. Like I said, go in and type it. It might seem confusing. It might seem overwhelming because this is like math being put in action. And this is what might be so fascinating to you, but at the same time, so overly whelming in a sense. But just know, you know, take a break. If it feels like too much, think about it for a little bit. You know, we're almost done with the video as well. That I think will be enough for today. But just know that the left side is always set to the right side. In our case, we're you know, checking what the variable is, counter on the right side, which is 0 in our case, and it's set to 1. We can run this again. So let's explain this a little bit further. We see that the loop is ran 5 times. Initially is 0, 1, 2, 3, 4. 0 counts as a time. So we could, if we were to label this, it would be like 1, 2, 3, 4, 5. All right, it's ran 5 times. We see 5 numbers right here. So let's kind of go through how that does that, just to so you fully understand loops and what's going on here. 0 counter is set to 0 initially. What a loop does is it's going to loop through stuff, but it's going to check this condition every single time. So this first time it's saying 0 is less than 5. We go down here. It's printing counter. Our first time it does this, you can see that it prints 0 because that's what counter is right now. And then we're going to set counter to whatever counter is. Right now it's 0 plus 1, so it would be 0 plus 1. That would be 1. We're not going to see that printed yet. I'm going to show you how it gets printed again. What the loop is doing is it's going to go back up now that it's finished this, because the loop isn't done yet. The loop is supposed to, you know, keep on running this code. And just to kind of prove that, we can print loop is finished. And if I save that and we run this, this only gets printed when, you know, the loop is done. So just to show, this won't leave until this statement is false. And you know, we kind of showed that earlier when I had the false in here. So we're going back up now. Counter is now set to 1. All right. If we were to print, you know, counter right here, which we do, we're going to see that it's 1. And it's going to check it is 1 less than 5. That's true. So this gets resolved to true, so we can continue with our loop. We don't exit the loop yet until this gets set to false. So we go down. We print counter, we see that it's 1. We increase it. We're going to check counter again. 1 plus 1 is going to be 2. Loop, this print statement doesn't get printed because we're not done. We got to go back up here and we got to check. Our condition is 2 less than 5. Yes, it is less than 5, so we're going to get true here. We're going to print 2, and then we're going to go down, and we're going to do 2 plus 1 is going to be 3, and then a 3 plus 1 is going to be 4, and then it's going to be, 4 plus 1, and it's going to get to 5, where counter is finally equal to 5. All right? When counter is finally equal to 5, like we said, this doesn't get printed. And we can see that if we run this, we only get loop is finished because it never ran, at least in this case of the program. But when you have counter here, when it's set to 5, this gets set to false. And that's when we get the loop is finished, as in within this case. So that's basically basically how loops first. When anyone refers to a loop, just know that a loop is going to have like some kind of conditional, potentially some kind of variable involved to have like a counter, as reference to it. And then you're going to have some way of incrementing within loops so that it can finally end. You can get input, like we said. I think if we run this, I'm not too sure if this works. Go down here. We can see that every time we press enter, for input, this runs infinitely, but okay, we don't even have to go into this. So yeah, that's basically loops. The only other loop that you're going to encounter is a for loop. In Python, I keep on doing this. It's just how other languages do it. So in Python, you have for I in range. This is basically probably the easier way to do a counter loop. For loops are meant to have counters. If we do this, you're going to see, okay, I need to kill this. You're going to see that for loops basically do what we just did, but a lot simpler. You're going to have your variable. In this case, it's I. We can name it to whatever. We can name it to our counter. You're going to have some kind of variable, like I said. You're going to have our condition, which in for loops, it's kind of sets this in range keyword. This basically says how far we want it to go, so we don't have to do that less than or greater than. This range already does it for us. And it's going to print I. Notice how counter doesn't initially get set, just to show this. How counter doesn't get initially set to anything. You can see that it prints 0 right away. So what in range does and what the for loop does is it will initially set counter to 0. Anytime you have a for loop, it'll initially set this variable to 0 right away, whatever's right here in range. And then range is just going to tell it like what's to go up to. And notice that it doesn't go up to 5. It's going to check up to 5, but it's not going to print it. Know though that we have 5 numbers. So anytime you have in range, know that it's going to do something 5 times. But it's always going to start with 0 with that number. All right. Another, common thing within programming is that variables start counting from 0. You're going to see this in many languages. If you do any like computer science classes, it's just something that's normal. Counting starts at 0. So notice that 0 is going to be like the first iteration that you do in anything. So that's how a for loop works. It's going to print whatever's within these, the indentation. And then we saw that it does basically the same thing. I encourage you to play around with this for loop and the while loop. That's going to be the best way that you can learn it. Like I said, this is already a lot for today. I think that I'm going to end the video for this portion here. The next video, I think we will get into functions. But I encourage you right now, if you haven't already, like I said, go, download Python, install it, start writing out the code, start do the for loops, do the variables, do all the examples that I showed, follow along with the tutorial, skip to whatever portions you want. If you don't understand something fully, ask GPT, copy the code, ask GPT what's going on with this code, ask it questions, be curious about it. That's the best way that you can learn is by being curious and by experimenting on your own. So that's why I highly encourage you to do, and I'll see you guys in the next video. If you like this video, subscribe to see all the next videos and everything else that I'm going to teach on this channel. I'm going to have a lot of tutorials in Python, maybe other languages, AI, all kinds of different stuff. Anyways, thank you guys for joining me. Leave a comment if you have anything that you would like me to teach, or if you have anything that you would like me to go into further. And we'll see you guys next time.